In this exercise, we are going, sorry, just start that again. In this exercise, we are going to look at integration by parts. And what we're going to do is look at two past paper questions. So the first of the questions, essentially, first off, let's remind ourselves how to go about doing integration by parts exercise. What we're going to do here is look at how to um, sort of set up our formula. So essentially what we're going to be given is given in the form, we're going to write in this form here, the integral of u dv, and the answer is going to be formulated as u times v, so you have these two expressions here, minus the integral of v du. Now that'll become clear shortly in a while. So we have u here, and later on we're going to need du. So we have u here, and we have du over here. That's a straightforward differentiation exercise. To find v, essentially what we're going to do is integrate the derivative dv. Now that'll become clear shortly what that is. Let's look at an example. This is Spring 2006, question 3a, part 3. And what we're looking at here is the integral of x times log of x dx. Okay, so what we have to do here is decide which part is the u term and which part is the dv term. Okay, so what we're going to do is let u equal to the log of x. Okay, so u is equal to the log of x, the natural log of x, and the derivative of that is simply 1 over x. dv, well, that is going to equal x dx. The integral, I should use blue here, I'll just keep going with red for the time being. So v is the integral of x times dx, and that is equal to x squared over 2. Now, just as a remark, you don't need to put in the coefficients of determination here, or the coefficients, the undetermined coefficients yet. You can leave them till the end, so we don't have to write in plus c yet, okay? So we have u, we have 1 over x, or du is 1 over x, and so on. Okay, so continuing on, so integral is equal to u times v minus the integral of v du. And now, let's just go back here. U times v is the log of x and times x squared over 2. So it's the log of x times x squared over 2 minus the integral of v du. So v is x squared over 2, and du is 1 over x dx. Okay, let's just see where that came from. I'll just bring this step out another bit further. This is the bottom line here. This is 1 over x dx. That would have helped. Okay, so that there is du. That is v. That is u. And again, that part there is v. So we set up the problem there. Now, all we have to do is work on is this second integration here. So what we'll do is simplify that. X squared divided by x, well, that just cancels out x over 2. We can get rid of that now as well. So we can re-express this as x squared over 2 times log of x minus the integral of x over 2 dx. That is equal to x, the integral of x over 2 is x squared over 4. Okay, get rid of that. And now we put in our coefficient, plus c, our undetermined coefficient, or unknown value. That's the answer there. Okay, so we can just break it up into component parts, but that is essentially the answer. That's a 4 there at the bottom. I sort of skipped this step where I integrated. I just sort of called that out. Let's look at 2006-7, spring 2006-7. I'm just going to pause it here while I write it up. So there we have it there. Integral of x times sine of x dx. In this case, what we're going to do is let u equal to x, and we're going to let dv equal to sine dx. Okay, du over dx, simply 1, straightforward enough. That means du is equal to dx. Okay, to find v, that's the integral of dv, which is the integral of sine of x dx, and that's simply cosh of x. And again, right now you don't actually have to put in the coefficient of determination. So we got these 4 values here, 4 expressions. We got that one there, that one there, that one there, and that's all we need actually. We only needed 3 of them. So v equals cosh of x. So we could just put that together. And again, just to recall that this is something you have to know off by heart, that the integral is equal to u v minus the integral of v du. U there was x, v was cosh of x, minus the integral of v, it was the integral of cosh. Du was just here is equal to dx. That's a simple enough one. The integral of that is sine of x. So the answer is x times cosh of x minus sine of x, and then we put in our coefficient there, plus c. So that's the answer to the second one. Those are 2 integration by parts examples, spring 2005-6 and spring 2006-7. And they're both part of question 3 in those exams, question 3A3.